Hey everyone, it's Sam. Today we're going to be talking about how to make your application faster with HTTP caching. This isn't caching like you are setting up the caching yourself. This is utilizing the browser cache, the Cloudflare CDN cache, and it's going to give you a lot of speed up in your application. I'm going to go through the sort of background with the RFC, how the headers work theoretically, and then we're going to jump into a practical example with a Rails application to show you how everything gets sped up and how to really make those interactions fast. All right, let's get started. Okay, let's dive in. I'm going to give you a little bit of an overview of how HTTP caching works based on the RFC 91111, which is right here. I'll link to it below if you want to check out the details, but I'm going to go over sort of the broad, very most general scope that I think applies to the most number of people. So how does it work? Well, caching works by looking at the request, looking at the HTTP request, and if it's a GET or a HEAD request, it will cache those depending on if the headers are set correctly, which we'll talk about in a second. And if the responses are 200s, 300s, or 404, then there's a possibility of caching. There are exceptions to this, but by default, in the most common cases, these are what can be cached, and this is the type of request that can be cached. So how does it work? Well, you have your origin server, which is your application. We're going to be using Rails as an example, and so I'm going to say the Rails server. So the origin is your Rails server. Then there's a cache, and then there's your user. The cache can either be the browser or the CDN. So for this case, let's just call it. Let's just say it's browser, and that means Chrome, whatever. And what happens is the user sends a request to the cache, or sends a request, sorry, to your application. And let's say it's looking up a CSS file. So the user sends the request to the application. Your application returns a response with the file and also sets a header called a cache control header. And the cache control header has a bunch of different directives, and the directives are used to define whether or not the response is cached by any number of intermediary caches. So in the real world, there's a lot of layers of caching that happens. So say you have your server, say maybe you have a CDN, and then the browser. So you're going to have at least two layers of caching there, which is the browser and the CDN. So what this cache control header does is it travels all the way back up from the web server to the user, setting the cache settings for this request on each of those individual intermediary caching mechanisms that you have. So what does the cache control header, what are the directives that you can set on the cache control header? The cache control header has a number, but we're going to go with the ones that are most important. No cache is the default most common one, which means that do not return a cached result for this request. So for this endpoint, so let's say the endpoint is, let's just add something here. Let's just say let's say the HTTP request is something like this: get request to profile photo.png HTTP 1.1. And if this is the request, this is the response is going to come with the image and then this header set, which says no cache, which means that none of the intermediary caches should return a cached asset of this, should return the cached response of this profile photo without, the key here is without first validating the item. So validation is something that we'll talk about in a second, but that's what no cache means. It will have to validate that it's the same item, and if it's not the same item under its validation, then it will return, it will hit the origin and it will send back a new request, causing more server load. A more strict one is no store. No store means do not even store the cache and have no possibility of ever returning a cache value. No cache, although it's called no cache, it has the potential to return a cache value if a validation passes. And validation is using Etags and last modified at, which I'll explain in a minute. So no store, no cache, those are pretty straightforward. But what if we do want to cache something? Well, we can set the max age. So you set max age equals, and this is the number of seconds that the cache can be alive, or what we call it is fresh. So the cache is fresh for a number of seconds. So let's say 3,600, which is an hour. So this means that this resource should be considered fresh for 1 hour. And the way that we determine if it's fresh is the cache looks at the age and then sees now versus the age, and then it has what's called delta seconds. So the delta between now and the age gives you the number of seconds that it's been alive, and if it's been alive too long, more than at max age, then it's considered stale and it will re-request from your origin server. So how is age calculated? Age is calculated by the first time that it's stored in the cache, and then the cache is in charge of keeping track of the age. So you don't need to worry about that. That's calculated by the browser and by Cloudflare, or by Fastly, or whatever CDN or cache layer you're using. And then another directive, so these directives are comma separated. So if you want to add multiple things at once, you will add a comma and then add them into this header. So another one, it could be must revalidate, which means that when the max age, when it has become stale, it must be revalidated on the server. Basically what it means is once max age is hit, it turns into a no cache until it's validated again from the server. If you don't have must revalidate, then it's possible that the CDN or the cache will serve stale data, which is fine in a lot of cases if you're just doing a static website. But there are situations where you want to make sure that it's not cached after you run out of the max age. So you can set this one if that's what you want to do. Another one is private. And then there's the opposite of that, which is public. So only set one of these. But if private is set, that means that only private caches should be used. Private caches would be something like a browser. It means it's very user specific. So you should only use private when you want to make sure that there's not the user specific content being stored on a shared cache. This could mean like a user's dashboard or something like that, where you want to make sure that that information isn't leaked to a cache like Cloudflare. Now, this doesn't necessarily imply that it's 100% going to be secure. You just want to make sure that intermediate caches aren't storing these responses, and it's user specific. That's what you want to think of with private. There is an older header called expires, which is used to give a date on when the cache expires, but I wouldn't recommend using that because cache control supersedes that, and if cache control is set, then expires is ignored. The only time you'd want to use that is if there's like an older system that maybe you're running through where it doesn't support cache control, the cache control header. So that's a little bit about how cache control works. Let's check out validation and how validation works. Let's go over here and look at Etags here. Validation is the act of validating whether or not the resource that the browser has is the same as, has been modified or not since its last visit. So Etags you can think of, they're called entity tags. You can think of as sort of just hashes of specific values. So for example, with Rails, if you have a Rails asset that's like a CSS file, you'll notice at the end there's like a hash. And that hash is actually used also in the etag. And that means that if you are returning etags, which Rails does by default, and I'll show you how to do manually if you'd like, then the server returns a 304 not modified. And the 304 not modified means that it doesn't actually need to return the value back because the browser already has the correct resource in its cache, and so we don't need to resend it back over the wire. The browser can just pop it and use it as it needs. So how does it know like which etags to use and whatnot? So basically, the etag is returned as a header, and it's gonna be a hash, so it's gonna look like something like this, and then the browser is gonna look at the request, and it's going to store this etag. Then, when it needs to revalidate, which we talked about with no cache, the no cache header, or must revalidate, then the browser is going to send a request with this header called if none match. So it's going to send the same request, same URL we're talking about here, if none match, and then it's going to include this etag in if none match. If the resource has the same etag, then it will match this, and it will return the 304 not modified response without any body. But if it has changed, then it's going to return the new information and also a new etag that it can use in the cache. There's another way that validation can occur, which is using the last modified header. And that's going to be a date for when the last time this resource was modified. Then, in conjunction with that, you can use the if modified since, then the browser, will use the if modified since header, and then that will send a date. And if it has been modified, since that date, then it will send you the new data. And if not, again, it will send the 304 not modified. That's a little bit of an overview about how caching works and how validation works. One final thing I want to mention is the vary header. The vary header will define a list of headers where you want to vary the cache based on those headers. So one of them is accept. So say you have a request to the same URL, but one has an accept header of JSON or XML, and the other one has a accept header of HTML, something like that. You want those responses are going to be different. So what you want to do is tell the cache to have different cache values based on this accept header. So if the accept header comes back as JSON or is JSON, then you're going to get the cached response correctly for the JSON. And if it's HTML, for example, then it's going to return the correct HTML. That way, you're not getting the wrong information, and it's also saving you. So in case different headers are going to be modified in different places, and you don't want to have to store a cache for each one of those. There's only specific headers where you really need to worry about having a different cache. So accept is one of those. Now that we have like a little bit of an overview of how caching works and how the headers work, I'm going to show you in actuality how it speeds up your application. Okay, let's dive in. This is running localhost, and then I'll show you in production with Cloudflare. This is just a little application I wrote to look at time zone overlaps. So it's all static content, really. It's dynamic in the sense that you can add new time zones, but when there's multiple time zones being added and we refresh the page, this value is always going to be the same. It's not going to update dynamically at all. So what we want to do is be able to cache these assets, cache these pages specifically, and there's a few things we need to do to set up our Rails application to do that. If you look with the default view here, let's reload the page. As you can see, the application takes 200 milliseconds. The whole thing takes about 477 milliseconds because nothing is being cached here, and we're all re-rendering all of this stuff as it happens. So what are some of the things that we can do? Well, for one, we need to enable dev caching so that we can see how the caching is going to work. So to do that, we just do Rails dev cache. That's going to turn on development mode being cached. And if you want to check out what that means, you can go over to the development directory here. And basically what it does is allows us to perform caching, but we're not worried about action controller caching here. What we're worried about is public files. And yes, in this case, public files. And then in the other cases, we're going to also add Etags to make things even faster. But in this case, we're going to add the cache control header, which we talked about, and public because it's a static asset. So it's not user specific. So we want this to be able to added to the public shared cache. And we're giving a max age of 2 days from now. Since Rails adds the hash to the end of the URL for the assets, actually what we can do here is we can do any amount of time because if it changes, it will be updated automatically. So you can do like 1 year, and that's still going to work fine for us. And what you want to also do is make sure to update production to have these cache control headers if you are serving assets from your application. If you're not serving them from your application, then you're going to need to update where you're serving the assets from to have the correct cache control headers. And again, we can update this to like 1 year or anything you want because the hash at the end of the URL is what is going to make sure that we always have a unique item. We have this cache control enabled for the public files because we're serving the public files here from development. And then let's just check out the page here, and we reload it. And we reload it again. And you can see, wow, it's a lot faster, obviously, because it's being served directly from the disk cache. Okay, so it's down to 0 milliseconds for all of these assets because they haven't changed and we don't need to update them. So let's just take a peek at one of these just to see. You can see that it's a 200 OK from the disk cache, and you can see here the cache control header that we set in this section. And this etag, which we don't need to use because we have this max age for a year, and so it's not actually going to need to validate it's not going to need to validate the data here. But what else can we do? We don't care only about the assets. The static page here actually could be cached, and while this has only 28 milliseconds, we could still make it faster by adding a correct etag. So let's check this out with curl, which is going to be a little bit faster for us here. So you can use I to just show the headers. And we're going to go to localhost here. And you can see that the etag is this F01. So as you can see, it changes every time. Because by default, Rails will give a different etag every request. But you can update it to use whatever you would like. And that gives us, let's go to the controller here, home controller. So how do we calculate, so we want to add etags to make sure that the etag is only updated when the content changes. And we can use the fresh when method of Rails. Fresh when will set etag and last modified, which are both important. And you can update, you can either pass an object in, which will make it automatically create the etag, or we can set the etag as we want. So let's do fresh when here to be etag. Let's add possible zones. Let's see here. What is etag? All right. Possible zones and time zones, because we want it to update based on if there's time zones added or if there's not time zones added. So for example, we have that etag, and that's going to give us this. And each time it's going to be the same, see? So that gives us these unique etags, which we'll be able to reuse. And so for example, if we update the parameters, which is the time zones here, we can see that the etag is going to update as well. But it's the same, but different than just the regular path, which is what we want. So that's a new etag. So what does that mean for caching? Let's check it out. What it means is, as you can see, instead of returning a 200, it returns a 304 not modified, which we discussed earlier, means that the response is, we don't actually return anything with the rendering of the response, as we can see in this, in our controller here, is rendered in, these are some great log messages I added. These is just 7 milliseconds. So you don't have to actually render any of the page because you get that 304, which is perfect for us. So we know that the etag is all we need because it's static based on these attributes, okay? And because it's public. So we have this all set up. Now we just need to set up Cloudflare, and we're going to show how to do that right now. Let's close this. So let's go to the Cloudflare dashboard. We're going to set up etags as well as the cache rules. So let's set up the cache rules here. Create a rule. We're going to call it TZ overlap. And when the host name matches, the beauty of this is you can make cache rules for a lot of different things, like specific paths only, or query strings, But for right now, I want the whole host to be cached. So I'm going to do tz overlap dot devscoach.com and eligible for cache. There's a bunch of settings you can do here, but for now, we just want to make sure that this is being cached. So we deploy that, and that's working now. And we also want to make sure that Etags are working. And so for Etags, there's a couple things you need to do. One is you need to make sure that this automatic HTTPS rewrite is off, which it is, because if not, it will rewrite your requests and remove the Etag header, which is not what we want. And the other thing you need to do is go to Scrape Shield and remove email address obfuscation, because that also results in the Etag being stripped from the response. Obviously, if you want to use these items, then Etags aren't going to work for you with Cloudflare, and you can use other caching. So now that everything's set up, and let's deploy this with our new Etag for the index. And I'm just going to deploy this real fast. And I'll speed this up and we'll get back to it after it's done. And I'll show you how it works in production. Great. Great. So everything has been deployed. So now we can check production and see how things are working. Let's go to overlap devscoach.com and let's inspect this bad boy. Let's disable caching just to show how it works before without caching. As you can see, we have 26 milliseconds. We have various things, 418 milliseconds. And since we just enabled caching, we're going to need to load it to make sure that everything is loaded from the cache. Let's get rid of this. And you can see all of this takes 0 because it's all in the memory of the browser cache, and which means that you don't need to actually fetch it at all. Now, what about this? We can see that we're also getting the 304 not modified. And let's just make sure the functionality still works. PDT, EST. And we can reload this page. So now it's caching the page, and we can see that it's very, very fast, obviously due to the browser cache. And so you might be wondering, is the Cloudflare cache working? So let's check with Cloudflare. We can see that the home page is sent with a bypass status. That is because it's not going to be cached because we're setting cookies to manage the session. If you turn off sessions, then you're actually able to cache the page itself. But since we're using Etags, it should be okay with the browser, depending on how heavyweight this is. But what we really care about is assets, right? So stimulus, for example. Let's load this. As you can see, there's a cache miss. And then it turns into a cache hit. Age is 5 seconds. The max age is this long. And so now every subsequent thing is going to be a hit, which is great. And that means that anything that's going through Cloudflare that follows these same attributes is going to be cached. So that's it for the quick overview of the caching with the browser, Cloudflare, and Rails. If you have any questions, please comment and subscribe for more content. Thanks.